So let's start with this example. Now, this is a solved solution, but I'll go at it step by step so that we understand, and I'll also share my approach in terms of drawing the shear moment diagram. Now, in the review of statics, we have some of the moments taken about a point to find all the reactions. So let's just start there. Okay, so in solving for this, I say that, well, first what you have to do is understand your unknown reaction. So your unknown reaction would be here and here. And all your problems should just give you no solution to reaction, so it's a matter of you solving for it. So just keep that in mind. And for this problem, the approach was to take it some of the moments about point A. So we can do that, and we can also do it some of the moments about point B. At the end of the day, whether you take it about point A or point B, it really does not matter, because when you take some of the moments about A, you'll get the unknown about B. And you notice, because if you just think of simple math, if you have one unknown from your equation, then you would be able to get an answer. So let's talk about it. So some of the moments about A, right? You want to go from left to right, right? Is 40 kilonewtons per meter multiplied by 8 gives you a reaction load right there, centered at there, between that 8 millimeters. So the center of that would be 4 meters. So what is the reaction? Well, the reaction is going to be 40 kilonewtons per meter multiplied by that entire width of 8 meters times 8 meters. And from a unit cancellation standpoint, you would get your result within a kilonewton, whatever value that is, right? I guess we could do it, 32.0 kilonewtons. And then that's our result force. And so remember to always repeat this when you do some of the moments. It's force times distance. And try to go in that order as much as you can as a system, so that you have a consistent approach. So force is the result force, which is 320, times distance, which is the centroid of that load, which is 4 meters. And if you can't see that, just imagine this thing as a rectangle, right? Imagine yourself as a rectangle. And so the question is, what is the area of that rectangle? Well, it's 8 meters times the height of 40 kilonewtons per meter, right? So the area of that is your resultant force. And then the distance applied is going to be the center of that rectangle, which is 4 meters. So here you got force times the distance. And if you carry that same thought process all throughout, we'll get a great solution. And we know that we say that clockwise is positive. And so we know that if it's about that point, so imagine that point that you're taking some of the moments, this point, imagine yourself that you are stapling that point and everything is about that point. So imagine yourself, you're at point A, right? You are there. You're right there. You're looking at all the load around you, and you ask yourself, well, if this is right here, about point A, that creates a clockwise rotation. Do you see that, clockwise? And then at B, we assumed that that is going up, so that creates a counterclockwise solution. And the 20 kilonewtons creates a clockwise solution. And that additional moment at the end creates a clockwise solution. So with respect to this, you've got positive direction, negative direction, positive direction, positive direction, and that sets you up for the rest of the equation. So let's start cleaning this up a little as it's getting messy. Okay. Okay. I'm gonna get pretty. Okay. So, in setting this up, all you're repeating in your head is force times distance. So let's set this up now. We agree that that's force, that's distance, this is your force, that's your distance, this is your force, that's your distance, and then the joker is this. It's 50 kilonewtons per meter. Now, that's not a force, that's a moment. So if it is a moment already, and remember, you care about the moment because that's your focus, right? That's all you do. You just take that right there and just drop it in there. And you ask yourself, is it in the same direction as what the assumption is? Yes, so that's why it's positive. And so from there, you have one unknown, one equation. So therefore, By is equal to 206.25 kilonewtons going upwards. There we go. So from there, we have one unknown left, which is at A. Well, guess what? We do sum of the forces in the Y. And so that game is just all about forces. So the question is, do we care about the 150 kilonewtons per meter? We don't. So then it does not appear in this. So imagine yourself, how does some of the forces work? Well, imagine you have sunglasses or goggles, whatever, and all you can see is vertical forces. That's all you can see. You don't care about horizontal force. You don't care about moment. All you care about is vertical force. So let's focus. Is this a vertical force? Well, it is, as long as you multiply it by 8, yes. Is that a vertical force? Yes, it's a reaction. Is this a vertical force? Yes, it is. Is this a vertical force? No, you don't see it. It's a moment. So therefore, that does not play a role when you're taking some of the forces. And so you get AY is equal to 133.375, right? And it's in the upward direction. And so that's how we solve this portion of it, if that all makes sense. And so in the next video, we will talk about how to develop your shear and moment diagram.